Hello everyone, my name is Ishwara Srinivasan. I'm presently working as a data scientist with Google AI Services team. I'm also an advisory board member here at AI for Good Foundation, and I'm very excited to share a talk with you about how to tackle data utility and data privacy trade off and how we can use federated learning in this situation. So, agenda for today will be talking about data privacy, what data utility is, and what's the trade off. Then we'll be talking about federated learning in a much deeper sense and talk about a case study where we're using federated learning. At the end, we're going to wrap up with the key takeaways from today's talk. So let's start from understanding what data is being collected from the users. So when people like you, me, and everybody else, we are using products that are developed by major organizations and major B2C organizations. We are using their applications and there is some data that's being collected. So, when we talk about data that's collected, they can be broadly classified as four different categories. It can either be a personal data, or they might be collecting engagement data, or they might be collecting behavioral data, or they might be collecting attitudinal data, or a combination of all the four of them. So, what is personal data? Personal data includes personally identifiable information such as your social security number or your government authorized number or your gender, as well as non-personally identifiable information including your IP address of the computer, web browser cookies, device IDs, etc. Then, what happens with the engagement data is it's a type of data about how consumers are interacting with the business's website. So, when you're using any application or either on mobile or computer or interacting with the social media pages through emails or paid ads, etc., they are trying to see how you're engaging with their product. Then we have behavioral data. Behavioral data basically includes any transactional details, such as your purchase history or your product usage information, like what kind of repeated actions you're taking, and any other kind of qualitative information about how long are you staying on their website. How does your attention span with the website look like, or the application look like, etc. The last data is attitudinal data. So, this type of data encompasses metrics on the consumer satisfaction, your purchase criteria, your product desirability, etc. So, basically, your attitude towards the products and your attitude towards proxies of the organization, right? Now, when we see that what data is being collected, the next step is to see how the companies are using the data. So remember one thing, whenever the product is free for you, when the organization is offering you a free product, you need to realize that it's free for a reason. It's free because you are the product for the company. The company is able to monetize itself based on how you're interacting with the product, how you're using it, and the data that they are able to collect based on your activities. So let's see how this data is being used, how the companies are using this data. One, to improve your experience. So whenever you're going onto an e-commerce platform and you're trying to purchase something, they're trying to improve your experience. They're trying to see that you're able to navigate through the website correctly, you're able to order what you require, you don't spend too much time browsing for some particular product that you're looking for, etc., and improving your experience. The second is, of course, refining companies' marketing strategies. If the company is focused on ads, then it has to figure out how does it cater to that need. If it's focused on sales of more product on the application, then it has to focus more on that. So depending on what the company's marketing strategy is and how does their business underlying strategy look like, they are going to use the data that you're providing with them to improve that strategy. Third thing is transform data into cash flow. As simple as it sounds, what it means is that the data that you're providing, they are using that to improve insights, to get information about how they can improve, how they can They can figure out ways of increasing your engagement with the platform, having you order more products, or having you have a better experience on the platform. So basically using your data to increase the cash flow. The fourth part is secure more data, of course. Like at the end goal, every business has to have more users, right? Like every business needs more users. So the way they can use this data is to figure out what kind of audience to reach out to, what kind of campaigns do they have for marketing purposes, or how do they increase the user engagement on the platform, and how do they secure more data in the same manner. Now, Now, the issue comes here with data privacy. So, what happens here is data privacy is defined about how a particular piece of information or data should be handled and who should be authorized to access this based on their relative importance. With the introduction of artificial intelligence, or you can see like machine learning and deep learning, a lot of personal information can be extracted from these models, which can cause irreparable damage to the people whose personal data have been exposed. So, here comes the need to preserve this data while implementing various machine learning models. So, organizations need your data to give you all the benefits that you are getting currently, to personalize the recommendation for you, to make the application easy to use for you, to give you what your needs are currently. And for that, they need data. So that's where the trade-off comes, where you want to see that, like the company is able to use your data to make the most of it, not just for itself, but also for the customers. And you of course want to have the best of experience when you're using applications. You want good recommendation models that help you reduce the amount of time that you put in to search something, right? So much consumer data has been captured and analyzed, and governments are crafting strict data and consumer privacy regulations designed to give individuals a method to control over how their data is being used. So in recent past, we have seen different kinds of efforts that have been taken place in this space. So for example, European Union's general data protection requirement, or GDPR, lays out the rules of data capture, how it should be stored, how it should be used, and how it's shared with companies. And the GDPR regulations and compliance doesn't just matter for the European countries. Here's why: because it's a law applicable to any business, literally any business that targets or collects the personal information of any of the European Union citizens. So, pretty much any kind of multinational company which has European customers, or who's using data from European users, need to comply with GDPR. Companies that ignore GDPR and fail to abide by their legal obligations to uphold customer privacy may face really high fines, up to 20 million euros, or up to 4% of their annual revenue, which one is higher. So this is something that they have laid out. Now, when we're talking about data privacy, it has made it to the US as well, in form of California Consumer Privacy Act, or CCPA. The CCPA here, in some ways, similar to GDPR regulation, but differs in that it requires consumers to opt out of the data collection rather than putting that on the service providers. So, whereas GDPR expects the companies to be more proactive about it, CCPA is focusing more about where you're giving that responsibility on the customers itself. It also names the state as the entity to develop applicable data law rather than the company's internal decision makers. So, data privacy regulations are changing the way businesses are capturing, storing, sharing, and analyzing consumer data. Businesses that are so far untouched by data privacy regulations can expect to have greater legal obligation to protect consumers' data as more and more consumers demand for these kind of privacy rights. And it's definitely going to happen soon, because more and more awareness is being made around data privacy. And there are a lot of ways that lawmakers and governance researchers have been able to figure out to make this a more safer place for organizations to also function. At the same place, make sure that the consumers are able to feel like to feel that they trust the solution and to feel that their data has been protected. So, data collection by private companies, though, is unlikely to go away. It will merely change in a form as businesses adapt to new laws and regulations. So, here's the trade off, right? For many companies, data sharing, interlinking, and mining are really essential parts of their business model. On one hand, insights delivered from rich data have been the driving force behind their growth by allowing access to not only data that discloses individual user behavior, social interaction, and spending, but also extremely sensitive information with details on geographical location, healthcare records, day to day routines, etc. The insights derived via mining user preferences are used to provide recommendations and enhance user experience. While, on the other hand, users have at times been exposed to unwanted personalized advertisement or data sharing to third parties and other kind of privacy breaches. There is a need for a fine balance between monetizing data while respecting and safeguarding the user privacy. In the world revolutionized by data and digitization, more and more personal information is definitely shared and stored, which opens a new field of preserving data privacy. But what is data privacy, and why do we see the need of preserving it is what we saw earlier. Now we're going to touch base upon one of the techniques called federated learning that researchers have come up with, and this is one of the architectural algorithms which talks about how data should be collected, how models should be trained in a way that companies are also able to derive insights from the data while the data is still preserved with its privacy with the customers or the users. So let's talk about federated learning, right? Federated learning is a new technology which enables the application on your phones to learn better while protecting your data and limiting it to your device. In this approach, our phone downloads a generic machine learning model. After your phone personalizes and improves this model based on the data that is literally on your device, it computes a summary about the changes that it has made. Thousands of such summaries are anonymously combined when the phones are plugged in to the charge so that it doesn't drain out the battery. So these summaries are now sent back to the central server. So now this summary is sent back to the central server where it's going to be combined to other anonymous reports, and then insights are going to be derived. So this provides a global improvement to the model that makes it work better for everybody. So you get a smarter phone and your data still stays in your hand. So, another important point about federated learning is it's also known as collaborative learning. And it's kind of a deep learning technique where training takes place across decentralized edge devices. So, these are your phones in your hands. So, all of them are decentralized, they are not connected to each other. Or, like, it could be other servers which contains personal data without really sharing the data. So your data is not leaving your devices, it's still within the boundaries of your device. While the data model training is happening on a centralized server. It aims at training the machine learning algorithm, say any kind of deep learning neural network, using the data, using the updated model weights that's coming out of each and every phone, and using that information to build a much better model on the centralized level. So that's how federated learning is working. So company is going to send out an update to each and every customer of its who's using their application, and then that model tuning is going to happen on your phones, and then the updated weights is going to be sent back to the organization. That way, they are able to gather information about you rather than you sending the data to them. So they're training the models on your devices itself. Now, one of the major concern that might arise is about reverse engineering, right? So, what one might think that what if the model weights that are being trained on your phone and are being sent back to the centralized server? What if it's reverse engineered, and would it cause a data leak, and would it reveal specific information or features about the individual users? This is a very valid concern, and the federated learning algorithm is designed taking the security aspect into concern. And hence, it does address this as well. Federated learning runs with something called as a secure aggregation. What this means is secure aggregation is an interactive cryptographic protocol with computing sums of masked vectors. So the model weights that are being sent from your phone are being masked. So there's complete encryption there. So it works by coordinating the exchange of random masks among pairs of participating clients such that the masks cancel out when a sufficient number of inputs are received. So when the individual encrypted model weights are sent back to the central server, the decryption is only happening on the aggregated weights. There is no decryption happening on individual model weights per se. So once each and every participating device is sending back the updated model weights, it's aggregated, and only at that point the decryption is happening. Now, the second thing is, what if the model captures specific data which might lead to to an individual being identified? Again, a very valid concern. So, what happens in this case is we have something called as a differential privacy, which is again part of the federated learning algorithm, which is an established way to deal with the risk of model memorization. So, model memorization is where the model is able to memorize very specific, unique kind of patterns in while training itself. So, where the model parameters might be too influenced by a single contributor. So, memorization risk can be mitigated by pre filtering rare or sensitive information before training itself. So whenever the central server is receiving all the new trained weights, if there's anything that's very unique or rare, that itself can be discarded and not used for the aggregation at the central level. So, differential privacy is a technique to measure the level of data privacy. Why I say this is depending on how sensitive the data is and in how much level of privacy is needed and should be enabled, the differential privacy algorithm can be altered. So we are trying to put a qualitative or rather a quantitative means on top of the data, and are trying to say that how much do we need privacy for this particular type of data. So depending on how critical it is, or like how sensitive it is, the degree of freedom that we have for keeping it private, or for keeping it at a high level of privacy, that might vary. So this could be done and this could be done in different ways to ensure that the individuals like prominently unique data isn't identifiable at the major level. So, a common method of doing it is to add noise to the data. So, you can add noise and disintegrate such unique patterns in the data. So, it can be done again like by adding noises at two different levels. So, what we have is a local differential privacy where we add the noise to the individual points of data from the single contributing user. So every user has multiple data points which is being collected. So we are adding noise at that granularity of the local data points. Whereas the other one is a global differential privacy where we are adding noise at a user level. So we are adding noise to the entire data set that's coming from one single user. Now, let's talk about how these models will be tested, right? Once you have collected individual model weights coming in from different devices, now it's important to see how the overall model has been trained and how the performance is. So, this is again that's happening at the user level. So, the testing of the model is again happening on your devices. So, once the overall central model is designed and trained, that model that model compute will be again sent back to your device, where the model is being tested. So based on your interaction with their application, or how they predicted your activities would be, they are trying to match your activities with their predictions and trying to see how good the model is doing. So here again, once the model is being tested on your devices, only the metric of concern, like it could be accuracy, it could be like F1 score or anything else, that will be sent back to the central server. So the testing itself is happening on the devices, and no data is being sent to the central server. So this is something that can happen in parallel, right? Like if you have millions of users, some of the users could be still helping you to train the model, while some of the other users might be testing the model. Now let's look at a case study. This is something which is very interesting because it comes from a financial institution where you have money at stake. Again, high risk kind of situation, and we see that anti money laundering is a major concern for most of the financial institutions, and most of them independently build models to ensure that money laundering doesn't happen, or like to red flag those kind of situations and predict in advance if something similar is going to occur. So, why is this a major challenge? Because every organization is limited to the data it has from its users, and there might be an overlap of the users between like organization A and organization B, but there are still different users who are enrolled into different organization, and each bank doesn't have um, all the information which is possibly existing. So here's where we can think about a way where all the organizations, all the financial sectors can come together and unanimously build a model that is able to be predicting money laundering situations in a much better fashion. In this situation, we see that even though the organizations can do this, there is an issue with sharing the data. Financial institutions are extremely strict with sharing their data because it contains very sensitive and personal information of the users. So what we can do here in this situation is use a federated learning model, and have each and every entity like bank A, bank B, bank C, and bank D, as you see in the figure, have them independently store their data as they were doing, and now we send a empty model or a untuned model to each of these banks and have them train that model on their ends. So there's no data sharing that's happening across different banks. So each and every model is being fine tuned at the bank level. And now the updated model weights from each and every trained model will be sent back to the central arbiter. So once it reaches back to the central arbiter, it is then aggregated together and then decrypted, and that's the final model that we come up with. So now our model, the final model that we have at the central level, is much more intelligent because it's having more data points than each bank could individually have. So this is how federated learning can be used in one of the case studies, and there's still research going on in this particular situation because it unanimously has to work with different banks, and there is a lot of processes that needs to be followed before something that's integrating different banks together is made. So now let's talk about the key takeaways that we saw in this session, right? For better personalization, you need better models. And for better models, you need better data, right? So, how do we build centralized machine learning model on decentralized data is something that's going to help us uh, deal with the data privacy and data utility trade off. So, what we're saying is data doesn't have to go to the server, and the model training is actually coming to the devices. So, your data is secure and the model is still being trained. And we are maintaining the data privacy while building really efficient machine learning model because it's now getting insights from different sets of data which was earlier not available to it. So thank you so much for coming in and listening to this talk. I would be very happy to take in any of your questions. So feel free to reach out to me through LinkedIn, and that's my profile that's on the screen. So please feel free to reach out to me and let me know if you have any questions. I'll be happy to answer any of them. Thank you.